Okay, this next topic is based on this sample question, which is probably one of the hardest topics in this chapter in terms of the math part. And it's still equilibrium, but the method we have to use is something called ICE, for initial change equilibrium. Okay, maybe it's just easier if we just do this sample problem. So let's look at this question. It says, at 1,280 degrees Celsius, the equilibrium constant Kc for the reaction Br2 gas makes 2Br gas, and the equilibrium constant Kc is 1.1 times 10 to minus 3. If the initial concentration of Br2, that thing, is 0.063 molars, and the concentration of Br, that one, is 0.012 molars, calculate the concentration of each of these species or each of these things at equilibrium. What that means is this is not at, these amounts given are not at equilibrium. These are just some random amounts. We want to know how much will we have at equilibrium. What few things I do know. The ratio of these things at equilibrium, the products over the reactants, well, this one Br squared over Br2 to the first power, products over the reactants is 1.1 times 10 to minus 3. But that's not what I was given. In fact, these ratios are not that. I need to find what they are at equilibrium. That's what this question's asking. So here's the equation again. What I'm given is the concentration of Br2, which is 0.063. The concentration Br at initially is 0.012. Here's my original equation. But they're going to change. This is where I say we'll go down by x. Br2 will go up by 2x. And I'm like, wait, fine, I understand the reactants can go down, and therefore products go up. And usually we say reactants are go down, minus x, and this goes up, plus x. But why is this plus 2x? Because coefficient 1, coefficient 2, minus 1x plus 2x. In other words, what I would do is I would say all the products increases by whatever coefficient is x, in this case 2 times x. All the reactants go down, that's why negative. And this coefficient is 1, so minus 1x. At the end, the equilibrium amount, if we start off at 0.063 and it goes down by x, at the end I'll have 0.063 minus x. At the end for Br, if there's originally 0.012 and it goes up by 2x, then at the end or at equilibrium of 0.012 plus 2x. This is also known as ICE, initial change equilibrium. In one of the other videos I made you guys watch, they also called it RICE, and R for reaction. But either way, ICE, ICE, initial change equilibrium. And so my equation, Kc for this, products over the reactants, the products over the reactants, the products over the reactants, the products over the reactants. Br, products, squared, because coefficient 2, over the reactants, Br2. Well, I know that is equal to 1.1 times 10 to minus 3. But what is the Br2 concentration? Sorry, Br concentration. It's 0.012 plus 2x squared. What's Br's concentration at equilibrium? 0.063 minus x. So I plugged in Br right here. Br2 right there. Plugged into the equation. Kc was given. It was given to us in equation 1.1 times 10 to minus 3. Now what I have is one big equation with x's. If I have this, I can now solve for x. And that's what the next slide is mostly about. So I need to find x. Once I solve for x, I can plug it in, and I'll have the equilibrium concentration of each one of these. So let's solve for x. Take this equation. Let me copy this right there. So I copied the equation. I'm solving for x. That looks a little bit daunting, but it's actually not that bad. This is why I say there's a lot of math. I can change this equation into this. Yes, I need to multiply both sides by the denominator, distribute, and I probably have to FOIL the top thing, combine all like terms, and I get this equation. 4x squared plus 0.04x, 0.048x plus 0.0000144 is equal to all that. And combine like terms now. Now I have some equation. You might notice the format of this equation. Is a format ax squared plus bx plus c is equal to 0. If I have an equation like that, I can solve for x. You know how to do that. I didn't say it's fun, but it's called the quadratic equation. So you'll plug in a for b is equal to 0.0491, c is equal to 0.0000747, plug into here, and I'll get two values for x. Like two values for x, that's really confusing. Which is the correct value of x? Well, let me first copy that chart that I had on the last slide. The initial change equilibrium. The equilibrium amount of BR2 is 0.063 minus x. The equilibrium amount of BR is 0.012 plus 2x. If I were to plug in this value of x for BR, I'll get negative 0.009. I can't plug in that value, the one that's circled, in for BR, because I'll have negative molarity. You can't have negative molarity. So what that means is I'll plug in that value and I get a positive number. If I plug in this value, I get a positive number, 0.00844. What that means is this one here gives me extraneous answers. This is an extraneous answer. This is the correct value for x. Plug these in, the amount of concentration of Br at equilibrium, 0.02 plus 2, this x, or 0.00844. The concentration of Br2 at equilibrium is 0.062 minus the correct value of x, 0.648.